A car weighs about 1 to 3 tons. If you want to lift up a car, you will probably need some metallic bars, hydraulic pumps, or even a crane. What else weighs about 1 to 3 tons? A small elephant. If you yourself want to lift up an elephant, you will also need metallic bars, hydraulic pumps, or even a crane. But actually, the elephant can lift itself up because its bones are strong enough. Nature grows amazing materials using abundant elements: carbon, oxygen, nitrogen, hydrogen. And nature assembles those elements in complex microstructure that have outstanding properties. And nature does it just like this, at room temperature, no pressure, and in presence of water. So, with my students and researchers at the university, we are developing sustainable processes to fabricate high-performance materials by taking inspiration from nature. We want our materials to be environmentally friendly, but also to have potential concrete applications, for example, in electronics or in construction. One first process we have developed grows ceramic polymer composites inspired from seashells. If you go to the beach, pick up a seashell, break it, put it under the microscope, this is what you will see. This is an aligned arrangement of ceramic microparticles held together with a little bit of polymer glue. We mimic this microstructure by starting with a suspension containing water, ceramic microparticles, and a little bit of polymer to be the glue. We cast this suspension, as you see here, onto a porous substrate that sucks out the water, leading to the consolidation from liquid to solid, from the bottom to the top, imitating a growth process. And as the sample grows, you can see the formation of layers. Now, if you take that sample, break it, put it under the microscope, this is what you will see. It resembles quite a bit the seashell we've just seen before, but actually it looks a little bit more complex. And this complexity is the key advantage we have as engineers, which is that we can really design the interior microstructure of our materials so that we can obtain the properties that we need for our engineering applications. In this case, depending on how the particles are oriented, you can tailor the mechanical properties, the electrical conductivity, the thermal conductivity. As an example of application, we took this suspension and put it in a small nozzle, deposit it, so that we can achieve higher resolution, as you can see here. Now, if you take that material, place it between electronic chips, you can channel the heat away faster, and you can prevent interferences between your electronic chips. This means that you can put more of these electronic chips in a smaller volume, ultimately leading to a smaller device. Recently, we have been developing another process, one that really grows a material, this time using a fungus. The process works as follows. We start with a 3D porous bioplastic scaffold, onto which we let the fungus grow. So here you can see white thing growing. This is the fungus on the scaffold. And it takes about 2 weeks for the fungus to entirely cover the bioplastic. This hybridization between the bioplastic and the fungus allows to combine the mechanical properties from the bioplastic, strength, stiffness, toughness, with the functional properties from the fungus, water resistance, temperature resistance, and even fire resistance. See how those two samples behave differently. The bioplastic scaffold without the fungus has a much bigger flame than the bioscaffold with the fungus. And that material here is entirely biodegradable. We think it could replace the clay bricks that we use to build buildings, or it could replace the polystyrene foam that we have in all of our walls that serves as thermal insulation and that is not biocompatible. So, with those two examples of processes, we can now start imagining growing our materials when we need them, where we need them. For example, if we have a construction site, next to it, we could have a temporary factory that would grow the materials to be used on that construction site. And actually, you could even grow it at home. So, with my wonderful group of students and researchers, we strongly believe that we can make manufacturing more sustainable. Our processes could be more environmentally friendly, more ethical, without needing to extract rare resources from the earth, without the need to transport materials around the world several times, even empowering citizens, creating new jobs, and still get the properties that we need for our applications. Nature grows amazing materials. Bone, seashells, trees. Surely we can also learn how to grow our own materials. In the future, every building, every object, or every device could tell a story not of extraction, but of regeneration. Thank you.